Today's lesson is on section 9.1, add and subtract polynomials. This first part of the first section of this chapter, actually, I'm just going to talk about some terminology and some words that we need to know going forward in our math career. When they talk about that first word there, or the last word there in the section title, polynomials, we need to know what this means. And plenty of other words that that I'm going to talk about today that are things we need to know going forward. When I say those words, or when you see them in the book, or other teachers say those words, we need to know what those kind of things are. Polynomials are actually things that you have dealt with before. We just called them some other name. We had another a term to use for those, another type of vocabulary. But now, again, getting into higher level math, we're going to call those polynomials. And there are different types of polynomials even. And I'll just kind of show a few examples here so we realize though what that is. First of all, realize that that prefix on the word poly, as some students, I'll ask them in class here if they recognize that prefix, and some will say that it means many or more than one. So polynomials means when we have more than one of these things, but just one of them would be a monomial. And so if you're taking notes along with me, that's the first thing I'd like you to write down. Definition of this word here is a monomial. A monomial, what is that? Well, it's a number, a variable, or the product of a number and variables with whole number exponents. And after reading through that, well, it still may seem kind of fuzzy, like, well, you're telling me this is something I've dealt with before. That doesn't sound very familiar yet, but I think maybe some of those first ones you could even see like a number or a variable. It could be something as simple as that for a monomial. So here are some examples of monomials. As we can see, it can be a number like 22. It could be a variable, even with a power like y squared, or the product of a number and a variable. So like 4x, negative 5xy squared, 7.4 n to the fifth. So all of these are monomials. In the past, I've even referred to them as another word. I've called them terms. And sometimes we talk about collecting like terms and how we deal with those in an expression. But now, given another word that you might see these referred to as, these are called monomials. Again, just singular, just one number or one variable. Or one, again, term, something like 4x, like this. Now, since I'm on this topic of just talking about one, like a monomial, then I can talk to students about, well, what if we have two of these things? We can have a prefix for that as well. So I'm going to jump to a different page here and talk about classifying different polynomials by their name. Kind of like these are monomials, well, we have other names for other ones. And so jumping to this page, I just want to talk about those different prefixes and again how we can classify different polynomials. So like we talked about this right here, 9x squared, this is just a monomial. So prefix for like one term we're talking about. So monomial, mono. That's just when I have one term there by itself. Binomial, bi is the prefix for two. So a binomial looks like this when I have two terms. Again, here I have 2 and then minus 6x to the fourth. So with those two terms, now I have a binomial. When I have an expression with two terms in. Again, in the past, we've maybe called those expressions or dealt with those. Maybe it was in an equation. If I had an equal sign in there too, maybe something I solved. So again, I want students to realize this isn't something brand new, but we do have some terminology for it, some new ways we refer to things like this. Again, this is called a binomial, and we will use that phrase very often in this chapter, this important chapter 9. When I have three of these terms, so 10y minus 3x plus 21. Again, something else we'll refer to a lot. When I have three of them, the prefix for that is tri. So, of course, what do you know? This is called a trinomial. When I have three different terms. So, and sometimes we'll do things in this chapter where we'll factor a trinomial into two binomials. Or maybe we'll multiply two binomials and get a trinomial, or multiply by a monomial. Like we'll do many different things, but they definitely need to know. Our students definitely need to know these words, what they mean. Biggest key I'd say is look for those prefixes. So mono means one, bi means two, tri means three. That'll kind of help you tell which type you have. Also, one more thing to note about this is again this section, this chapter deals with polynomials. All of these are still polynomials. So even this is a polynomial, this is a polynomial, and this is a polynomial. Sometimes we can describe them or classify them a little more specifically, like monomial or binomial or trinomial, but they are all polynomials. So any of these can be classified under that heading. It's kind of like I likened to when we talked about earlier in this year. Sometimes we talk about like whole numbers. Whole numbers are 0, 1, 2, 3, 4, 5, and on and on. But whole numbers can also be called integers. They also fit that category. They also are rational numbers. They're also real numbers. But sometimes we can call them by the most specific name we have for them is whole number. That's kind of how these classifications fit in as well. All of these are polynomials, but to be more specific, we might call the first one there a monomial, the second one a binomial, third one a trinomial. It's just classified by how many terms are in that polynomial. So then jumping back to this page, now talking about monomials and binomials, trinomials, we'll see all those things. But going back to just monomials, like one term by itself, we also talk about the degree of a monomial. And that is just the sum of the exponents of the variables of a monomial. So what I'm looking at is the exponents of the variable part. So in one like this, y squared, okay, it says the sum of the exponents. So I don't really have any to add together. It's just that one term by itself there. So the degree of a monomial is just whatever the exponent is. So in this case, it'd be 2. In 4x, there's no exponent on the variable x, correct? But that means it's just implied that there's a 1 there, so the degree of this would be 1. The degree of this last one, 7.4 n to the 5th, would be 5, because it's got an exponent of 5. The degree is just the power of the exponent. And if there's more than 1, I'll have to add them together. So looking at this one right here, negative 5xy squared. Well, each of those variables would have an exponent. I can see that the y has a squared power. X, even though, has a power with it as well. It's just to the power of 1. So here's where it says the sum of the exponents of the variables. So now if I'm talking about, well, exponent of 1 for x and 2 for y, I'm going to add those together. This has a degree of 3, this term right here. And I think I have some of these below as well. Yes, so you can see I have some of these same examples below, which is fine. So this first one here, 7.4 n to the 5th, again, like we talked about, that has a degree of 5, because we're looking at the exponent here that's on the variable part. Again, we talked about this one, 4x, will just have a degree of 1. And y squared, that'll have a degree of 2, again, because of the exponent here. What about a number like a constant, just 22 by itself? Well, again, this specifically talks about the exponents of the variables. So if we're just talking about the exponent of the variables for a term, well, then this 22 doesn't have a variable associated with it. So I'll usually ask students if they got a guess for this one, and usually they'll be able to come up with actually this has a degree of 0. So if it doesn't have a variable with it, that's just degree 0, just a constant. Then just these last two to emphasize, again, like it says, the sum of the exponents of the variables. So in one like this, I'd have to add 7 plus 3 plus 11. That term altogether would have a degree of 21. And then we did this one above again. One might actually see negative 5xy squared. X has a variable of 1, or an exponent of 1, really. So 1 plus 2 would give me a degree of 3 for that term. Why will we talk about the degree of any kind of monomial or any polynomial? Well, one thing that students will learn in the future is that if you know the degree of a polynomial, you will know what the graph of that polynomial will look like. And again, that's something they'll learn more and more as they go on in math, or you will learn more and more if you're the one following along here as a student. So that's something that you will find is pretty important, to know the degree of your polynomial. Also, we'll just talk about how we organize a polynomial. Usually we go in decreasing degree order. That's typically how we'll write it, but we'll get to that here in a few pages, and I'll show you what that looks like. So again, up top there, I've already kind of talked about polynomials, but you can jot down that definition as well. A polynomial is a monomial, or the sum of monomials. So yeah, it could be 1 term, or 2 terms, or 3 terms, or as many as you need, but all those are classified as polynomials. So for example, here's a polynomial, 4x plus negative 5xy squared. Or this one also, 6x squared y squared plus 5x minus 20. Those are both polynomials. We talked about finding the degree of each individual term, or each monomial within that polynomial. We can also talk about the degree of that polynomial. Again, we talked about that's how I mentioned that's what's going to determine the graph of your particular polynomial if you're trying to graph it down the road. But I can jot this down. If I'm talking about the degree of a polynomial, it's just the greatest degree of all its terms. So I don't have to add all those up. But if I'm talking about the degree of a polynomial, I just look at the degree, the one that has the biggest degree. So let's go through these polynomials right here. This one, 4x plus negative 5xy squared. So what I'll do is I'll figure out the degree of each of these terms. So 4x, well, that would have a degree of 1 like we talked about on the previous page. And negative 5xy squared, again, the x itself will have an exponent of 1. And 1 plus 2 give me 3. So this one will have a degree of 3. So this polynomial will have a degree of 3. And again, knowing that, it would be in the future we'll determine how we can graph it, and we'll talk about rewriting it here very soon too. Okay. But for now, just going on to the next one here, talking about the degree of this polynomial. Well, the degree of this first term is 2 plus 2. It's 4 if I add the two exponents together from the variables. The degree of this term is just 1. And the degree of any constant, remember, is just 0, so because it doesn't have a variable part to it. So the degree of this polynomial would be 4, because it's the degree of just the largest one. So the degree of any polynomial is just the degree of the greatest degree of each of one of the monomials. Whatever one has the greatest degree, that'll be the degree of that polynomial. One way we'll practice working with the degrees of different terms and the polynomial is whenever you usually write a polynomial down, you usually write it in decreasing degree order. So for like number 1 here, first thing I could do, it says write the polynomial so the exponents decrease from left to right. So it's just kind of like the degrees like we were doing on the previous page. I could find the degree of each of these. So 6x, so that'll have a degree of 1, because again there's a variable of 1 here on the x if I don't see it there. 21x to the third will have a degree of 3. 19 will have a degree of 0. And 8x to the fifth will have a degree of 5. Typically when you write polynomials, you write them in decreasing degree order. So the first term I'm actually going to write here, if I'm going to rewrite this thing, is actually over here, the negative 8x to the fifth. And make sure you do keep an eye on that. The sign in front of this is a subtraction sign. So I have to think of that like negative. So I have to bring that with when I rewrite it. Negative 8x to the fifth. What I like to do after I've written them is I just kind of cross it off and go on to the next one. Well, now I've got negative or minus 21x to the third. Again, that subtraction sign has to stay in front of it. So minus 21x to the third. And then I've got plus 6x and then plus 19. So there's my polynomial written now in decreasing degree order, or decreasing in exponents from left to right, either one. Both mean the same kind of thing. Number 2 here. Same idea. I can find the degrees of these pretty quickly. This one just has a degree of 3. A constant by itself just has a degree of 0. Negative z to the fourth, so that'll be a degree of 4. And z by itself is just a degree of 1. So if I write them in decreasing degree order, I'm going to start off here with the highest one. So negative z to the fourth. And then my next one would be plus 2z to the third. Then plus z. And plus 2.5. And that's typically how you write a polynomial. So if they want you to rewrite them, I'll just make sure that I write them in decreasing degree order. Go through one more here together. This first term, 8x to the third y. Again, the y would have an exponent of 1. So this would really have a degree of 4 when I add those two together. 17x to the seventh would have a degree of 7. X to the fifth would have a degree of 5. And xy squared, again, will have a degree of 3. Because there's that exponent to the x's to the first power, really. So I add them together and get 3. Again, rewriting these. So I start with this one first. 17x to the seventh. Minus x to the fifth. And then over here to the fourth degree will be the next one. So 8x to the third y. And then plus xy squared. Now one more thing they'll talk about. So we can write these in decreasing degree order. And we can determine the degree of each polynomial. Again, that would just be the biggest one. So this last one here would have a degree of 7. That middle one would have a degree of 4. Problem number 2 we did. The first problem we did there would have a degree of 5. Again, it's just the degree of the biggest term, the term that has the greatest degree. So we could find that. Something else they might mention too in the homework. They might also talk about the leading coefficient. And again, this will also be something that'll be more important as time goes on. Something we'll realize can be an important factor when graphing or when solving a problem. But the leading coefficient is just the coefficient of the first term when we write them in decreasing degree order. So you might just label this the LC, leading coefficient. So now that we've got it written in order, well, then it's just the very first coefficient, the very first number that I've got here. So in this case, the LC would be 17 for this problem. And it has a degree of 7 because, again, that's the exponent we found here. Okay. Going back to number 2, I'm just kind of going back to these backwards here, but the LC of this one, we've got it written in order. So it's just the coefficient on the first term. Well, it's negative z to the fourth. So remember, there's like a 1 there if I don't write that number in. So the leading coefficient of this one would be negative 1. And again, it'd have a degree of 4 from that exponent that we saw here in the first term. And the very first one, the LC would be negative 8. Again, because of that negative 8 after we've written it in order. And the degree would be 5 from the exponent. Last thing I want to talk about here in this first part of the lesson. So we talked about what a polynomial is, and we got a definition there for monomial. To kind of keep that in mind, it's a number, a variable, or the product of a number and variables with whole number exponents. So then we'll talk about, well, there are some things that are not polynomials then that we could still deal with. And actually we dealt with them a bunch in the very last chapter, chapter 8. What are some things that are not polynomials? I'll usually ask students, and they can usually come up with a few of them, the few that I have on this list here. One of them, something we dealt with early in chapter 8, was negative exponents. So something with a negative exponent is not a polynomial. It's some kind of term, some kind of expression, something we know how to do with, but it actually is not considered a polynomial. It's not under that definition. But still something we know how to handle, what we can do with those kind of things. So that's not considered a polynomial, though. Another one that kind of goes with negative exponents, think about how we would rewrite this. I would make this into a fraction and put 3 over x to the fourth, correct? Because that negative exponent means just kind of take the reciprocal of it or put it in the denominator of the problem. So we could rewrite it like that. That's actually my number 2. So 1 and 2 kind of go hand in hand here. So negative exponents, or if you see an x, the variable in the denominator. So that's kind of what you have in this part here. So those two, 1 and 2, are very close to the same thing, actually. If I rewrite negative exponents, I have a variable in the denominator very often. So those two you can kind of think of together. And the third one here is also something we dealt with just recently in chapter 8. 3x plus x to the 2 to the x power. If I have x as an exponent in my problem 2, that is also something that we can deal with. We've dealt with exponential problems, but it is not a polynomial by their definition. Again, this first lesson, just getting down some of this terminology, but this will help us a lot going forward, knowing what all these words mean when I say them in class, your book says them, or when future teachers talk about them as well.